Hydrocarbon exploration, or oil and gas exploration, is the search for deposits of hydrocarbons, especially petroleum and natural gas. The exploration activities are mainly led by petroleum geologists and geophysicists. The main goal of the exploration is to obtain enough information needed to exploit the best opportunities for further drilling and producing oil and gas. Zafar Platform is an oil production platform in South Chinese Sea, approximately 25 miles northwest of Sabah, Malaysia. The project was run and the platform is being operated by Sabah Operating Company. It began the production in 2017 as an oil and gas production platform. Since the drilling costs make up the substantial portion of the total exploration and development costs before drilling the exploration wells, the geological history of the area, which is Sabah State, was studied and the likelihood of the carbon reservoirs in the subject area was investigated. The 3D model of the reservoir was created in order to improve the estimation of how hydrocarbon composition and making decisions regarding to the development of the field. As favorable results are obtained from the geological survey, the company hired semi-submersible drilling rig to drill exploration wells. The geophysicists record the seismic waves to learn about oil and gas reservoirs located below the surface. The discovery drilling works were carried out in 3 different areas within the South Chinese Sea close to Sabah State between 2010 and 2011. After a month of exploration, the exact location of new drilling wells was decided. These wells were drilled by using a drilling rig, and after the wells proven to be able to produce hydrocarbons as expected, Sabah Operating Company continued the drilling activities in the field before constructing and placing a permanent production platform. There were already 2 other gas production platforms in the discovered oil field. Therefore, the composition of the hydrocarbon reservoir is well understood. Welcome back to our course. Today, we will talk about reservoir fluid origin and the required parameters used to identify reservoir conditions. Let's jump on the details. In petroleum science, the reservoir fluids are the fluids contained within the petroleum reservoir, which technically are placed in reservoir rock. The reservoir fluids normally comprise liquid hydrocarbons that are mainly known as crude oil, then aqueous solutions with dissolved salts, hydrocarbon and non-hydrocarbon gases such as methane and hydrogen sulfide respectively. These fluids are brought to the surface as a mixture of oil, gas and water, which is sent to the surface production facility before they can be disposed of or sold to an industrial customer. The formation of such fluids in the reservoir rocks begins in warm and shallow oceans that were present on the Earth millions of years ago. In these oceans, extremely dead organic matter, classified as plankton, falls to the floor of the ocean. These plankton consist of animals called zooplanktons or plants called phytoplankton. This material then lands on the ocean floor and mixes with an inorganic material that enters the ocean by rivers. It is this sediment on the ocean floor that then forms oil over many years. The energy in oil initially comes from the sun. This energy from sunlight is trapped in chemical form by dead plankton. The formation of the Zafar fluid also followed the same path as other oil and gas reservoirs. Zafar fluid will originate from both Ardabil and Karabakh reservoirs. The major part of the Ardabil content will originate from Ardabil 5th horizon, along with some contribution from Ardabil 2nd, 3rd, and 4th reservoirs. Karabakh fluids will consist of fluids from both the upper and the lower horizons. Well, let's talk about the reservoir conditions. The reservoir conditions are beyond the scope of chemical engineers, but it's worth to learn some information about the conditions of our main reservoirs that are Ardabil and Karabakh. Generally, reservoir conditions are different and specific individuals to each reservoir. 2 dominant variable conditions affect every petroleum reservoir that are pressure and temperature. The differences in fluid and pressure and temperature between one area and another determine the pressure and temperature gradients, which are fundamental to most problems involving the movement of oil and gas through the rocks. This movement may be a migration that permits oil and gas to accumulate to form a pool, or it may be a movement of oil and gas from a pool into a wellbore. Much of petroleum engineering has to do with relations between pressure, volume and temperature, or as they are commonly called collectively, PVT. The volume changes are most pronounced in gas content of the reservoir, but they also occur in other fluids, the water and the oil, and to a lesser extent in materials that constitute reservoir rock. Abnormal fluid pressure gradients and any temperature gradients indicate that energy has changed from potential to kinetic, and that work is being done. Apart from the pressure and temperature of the reservoir, TVD, which is true vertical depth, and GOR, that is gas to oil ratio, are also parameters used while defining the reservoir conditions. True vertical depth is the parameter that is defined by measuring vertically from surface down to a certain target downhole. The gas to oil ratio is the ratio of the volume of gas that comes out of the solution to the volume of oil at the standard conditions. As we define all the required parameters using defining reservoir condition, let's look at the conditions of our reservoirs. As you can see from the table, our RW third reservoir operates at 251 bar and 60 degrees Celsius with 1250 gas to oil ratio and from 2300 meters vertically below the surface. You can also analyze the conditions of our other reservoirs from the table provided. Please note that all above GORs are nominal figures that are conservative design basis. The GOR will vary throughout the field life. Alright, let's summarize what we have learned in this lesson. The first, we talked about the significance of and formation of the reservoir fluids, and then discussed the parameters like TVD, GOR, pressure and temperature that are needed to characterize the reservoir conditions. Well, I hope you find out how mysterious are the reservoirs. So see you in the next sessions. An oil and gas reservoir is a formation of rock in which oil and natural gas has accumulated. Conventional hydrocarbon reservoirs consist of three main parts: the source rock, the reservoir rock, and the cap rock. The source rock is the rock that contains the cargon that the oil and gas forms from. The reservoir rock is the porous permeable rock layer or the layers that hold oil and gas. Then the cap rock seals the top and the sides so that hydrocarbons are trapped in the reservoir while water often seals the bottom. Reservoir rocks need to be both porous and permeable, and this means that there is a small pockets of space within the rock where oil and gas can settle. And small channels connection allows oil or gas to flow out this rock easily when it's drilled. These spaces between the grains can develop as the formation of rock that occurs or afterwards, usually as a result of groundwater passing through the rock and dissolving some of the cement between the sediment grains. The oil and gas is pressurized in the poles of absorbent formation rock when a well is drilled into the reservoir structure. The hydrostatic formation pressure drives the hydrocarbons out of the rock and up into the well. Gas, oil, and water are extracted and level shift as the reservoir is depleted. The seismic data and advanced 3D visualization models are used to plan the extraction. When 3D seismic investigation has been completed, it is time to drill the well normally. The dedicated drilling rigs, either on mobile onshore units or offshore floating rigs, are used here. Larger production platforms may also have their own production drilling equipment. You may have noticed the term upstream in the objective section. If you are going to work in the oil and gas industry, you will hear this and a couple of words like those almost every day. The terms upstream, midstream, and downstream are used to mark three main segments in the oil and gas supply chain. Now, let's start defining with upstream processes. Generally, upstream processes can be simply defined as the set of processes and activities needed to locate and extract the materials for production. To be more specific, in the oil and gas industry, the upstream process refers to activities like an exploration of the reservoirs, drilling wells, and extraction and even initial production of oil and gas from the deposits. Oil and gas that comes to the surface go through the several physical processes like separation to prepare material for export and compression in order to reach required export pressure. After that, the next part of oil and gas supply chain commences, that is midstream. This segment refers to anything that requires to transport and store crude oil and natural gas before they are refined and processed into fuels and key elements needed to make different products that we use every day. The midstream includes pipeline and all the infrastructure needed to move these stores to long distances, such as pumping stations, tank trucks, real tankers, and transcontinental tankers. However, it is mostly referred to as bridge between upstream and downstream processes. And finally, the downstream processes includes a set of activities like processing, distribution, and sale of the product. The oil refineries are the good example of downstream operations, where a set of physical and chemical processes are carried out for converting the crude oil into ready-for-sale products. Hello everybody. Today we're going to delineate the process flow diagram of the Zephyr platform. Let's start. Developing the complete flow diagram of any platform system requires enormous amount of work and true data. Therefore, most of the process engineers spend hours and hours to gather all of the required values and then in the end generate a full system after millions of updates. Well, on the whole, the platforms comprise mainly of separators and pressure-creating devices. In our Zephyr platform, two-phase mixtures from LP, low pressure, and HP, high pressure manifolds enter the corresponding separators in order to remove liquid and gas parts of the mixture from each other. To be more precise, the mixture entering HP separator working at 40 degrees Celsius and 2901 kPa is processed under high pressure conditions. And then it is the pressurized liquid from the bottom part of the column comes into LP separator working at 35 degrees Celsius and 1401 kPa. Moreover, the bottom product of this column is the liquid, which needs to be transported to onshore for further processes or for direct sale. As the distance between the offshore platform and onshore platform terminal is huge, the liquid needs to have a certain level of pressure value to overcome the sum of pressure losses on the way and the pressure at the entering point. This pressure is generated with the help of two consecutive pumps. The first pump, booster pump, which is slightly smaller, serves for increasing the pressure of the liquid to the determined mid-pressure value of 2800 kPa. Right before the entrance of the main pump. This pressure increase is specially determined through the several steps of calculation and aim to prevent formation of cavitation, meaning high pressure collapse of bubbles formed due to the boiling of two mixture low pressures in the pump. And after that, the second pump, or the main oil line pump, increases pressure of the export fluid to 6601 kPa, which is quite enough for the liquid to reach the onshore terminal. At the same time, the vapor leaving from the top of the column gets into the suction scrubber 1 that removes all of the considerable liquid particles from the vapor before entering into the flash gas compressor. The compressor, whose main purpose is to bring the vapor to the same pressure as the vapor leaving from the top of the HP separator, increases the pressure of the vapor from 1401 kPa to 3101 kPa. However, immediately after going out of the compressor, the vapor enters into the cooler to give its excess heat away prior to joining the HP vapor. Once these vapors are mixed, they once again get into the cooler for further removal of the heat to 16.12 degrees Celsius. Unfortunately, all of the cooling procedure results in the creation of the liquid particles inside the mixture, and these are removed in the inlet scrubber of the glycol contactor, where the components which cause the formation of the hydrates are separated from the mixture with the help of glycols. This system takes the advantage of glycol regeneration system, where the glycol mixture used in the system is regenerated. Subsequently, the hydrocarbon fluid which gets out of the contactor enters into the second suction scrubber, which removes the liquid particles and then is mixed with scrubbed liquids from the first inlet scrubber. After that, this whole mixture is dispatched to the flare system, and simultaneously the vapor of the second scrubber is transferred to the gas export compression, where its pressure gets increased to 7101 kPa. And as a final stage, the vapor is moved to the onshore through the export pipelines. Thanks for watching. Have a good day.